In this clip, we're going to talk about different types of geologic structures and what those geologic structures look like on a geologic map. Simplest type of geologic structure is a fold. There are two basic types of folds. The first is called an anticline. An anticline is one where rock layers have been squeezed upward. In other words, if we apply compressional forces to these rocks, younger rocks on top, older rocks on bottom, what do? We cause the rock to bend. This is called a fold, and the particular type of fold we get is one where older rocks are in the middle of the fold and younger rocks are on either side. In other words, if this fold was to be eroded and leveled, what would it look like? We would see older rock in the middle of the structure, younger rock on either side. In other words, on a geologic map, an anticline would be an area of older rock with younger rock on either side. This is the cross section, a vertical slice showing what the structure looks like. This is the map view, as if we were looking on the structure from top down. We have older rock in the middle, younger rock on the edges. A syncline is the opposite of an anticline. A syncline is a downward fold, which allows younger rock to accumulate in the middle with older rock on either side. What would a syncline look like on a geologic map? It would have the opposite age relationship as an anticline. In a syncline, we're going to have younger rock in the middle with older rock on either side. Domes and basins are circular structures. You can think of these as circular anticlines or circular synclines. A dome is caused by uplift across a broad region. Such that we have older rock exposed in the middle with younger rock surrounded by younger rock around all the sides. In other words, we've pushed older rock up from below. Erosion has exposed that older rock in the center of the structure. We call that structure a dome. A basin is the opposite of a dome. In a basin, we have subsidence across a broad region, allowing younger rock to accumulate in the middle. And that younger rock is surrounded by older rock on all sides. If we were to take a cross section through our basin, what would it look like? It would look like a syncline. Younger rock in the middle, older rock around the edges. If we took a cross section through a dome caused by uplift, exposing older rock in the middle, what would a cross section through a dome look like? It would look like an anticline. This is a geologic map showing a portion of the Midwestern United States. The different colors on the map represent the age of rock that is exposed to the surface. In other words, the geologic period in which that rock was formed. In the map key or legend, older rock will be at the bottom, younger rock will be at the top. In other words, Precambrian rock is the oldest rock exposed in this map area. and Cretaceous rock is the youngest rock exposed in this area. We can look at the relative ages of rock units to infer the type of geologic structure shown in any particular part of the map. For example, what would a dome look like on the map? Again, a dome, we have older rock in the middle, younger rock around the edges. In other words, to recognize a dome on a geologic map, you're looking for a circular pattern, and the relative ages of those rocks should place the older rocks in the middle and the younger rocks around the edges. How many domes can you find on this map? Well, this is a dome. This dome is called the Ozark Dome. It's located in southern Missouri. We can find that we have old Precambrian rock in the middle, surrounded by younger Cambrian, Ordovician, and even Mississippian rock. How many other domes can you find? Well, here's another dome. We have older Ordovician rock surrounded by younger Mississippian rock. Are there any other domes in the map area? There's this one here. This is called the Cincinnati Arch. We have older Ordovician rock surrounded by younger Silurian and Devonian rock. Again, we have identified 3 domes in the map area, places where we've had uplift across a broad area, and then as erosion wears away at that uplift, we find progressively older rock exposed in the middle of the structure. Progressively older rock in the middle of the structure surrounded by younger rock. Basin is the opposite of a dome. Here we have subsidence across a broad region. That subsidence allows younger rock layers to accumulate in the center of the structure and older rock layers surrounded on all sides. How many basins can you find in the map area? Well, there's one basin here. This is the Illinois Basin. We have younger Pennsylvanian rock surrounded by older early Pennsylvanian and Mississippian rock. Can you find any other basins in the map area? There's another one here. We have young Permian rock surrounded by progressively older Pennsylvanian and Mississippian rock. Finally, we have a basin here on the lower peninsula of Michigan, the Michigan Basin. The youngest rock in the structure is Jurassic in age. It's surrounded by progressively older Pennsylvanian, Mississippian, and Devonian rock. Again, basins caused by subsidence across a broad area, allowing progressively younger rock layers to be formed or preserved in the center of the structure. Older rocks surround the edges of the structure. This figure shows a cross-section, a vertical slice through this part of the central U.S., revealing the Nashville Dome, an area of uplift, exposing progressively older rock, and the Illinois Basin, an area of subsidence, allowing progressively younger rock to accumulate or be formed in the center of that structure. This vertical slice shows that a basin is basically a circular syncline, whereas a dome is basically a circular anticline. Can you find any anticlines in the map area? Anticlines would be an area of older rock with younger rock on either side. There's an anticline here. That anticline has Devonian rock in the middle, surrounded by younger Mississippian rock. There's an anticline here. We have older Ordovician rock in the middle, surrounded by younger Mississippian and Pennsylvanian rock. What about synclines? Can we find any synclines in the map area? A syncline would have younger rock in the middle, older rock on the edges, the opposite of an anticline. Can you find any synclines in the map area? Well, what about this one here? Here's a syncline. We have younger upper Pennsylvanian rock surrounded by older lower Pennsylvanian rock. So this part of the map area, the relative ages of rock units exposed in that part of the map area reveals the presence of a syncline.